Class 10, Chapter 6, Triangles, Module 3. Objectives. In this module, you will learn about Pythagoras theorem. Now listen carefully, students. Before the Pythagoras theorem, we need to write one connection theorem. It is important. Okay. So, if a perpendicular is drawn from the vertex of the right angle of a right triangle to the hypotenuse, then triangles on both sides of the perpendicular are similar to the whole triangle and to each other, or similar to each other. That is, in the above figure, triangle ADB similar to triangle ABC, the whole triangle. Same as BDC similar to triangle ABC. And also triangle ADB similar to triangle BDC. Okay, so this one is what? Connection theorem. So we want to apply this connection theorem in this Pythagoras theorem. Okay, now the next one, Pythagoras theorem. In a right triangle, statement is this one. In a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So, once more, in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. That is Pythagoras theorem, that we know. Now, listen carefully. In this figure, angle B is a right angle of triangle ABC. We need to prove that AC square is equal to AB square plus BC square. For the construction, draw BD perpendicular to AC. Now in triangles ADB and ABC, angle ADB is equal to angle ABC each 90 degree, and same as angle BAD equal to angle BAC, each angle A common. So triangle ADB similar to triangle ABC using AA criteria. Now the next one, if the two triangles are similar triangles, we can write the sides as proportion. That is AD by AB, the whole one. AD by AB is equal to AB by AC. Or when you cross multiply, AB square is equal to AC into AD. Put equation number 1. Similarly, triangle ADC similar to triangle ABC. So we can write the sides proportion as CD by BC equal to BC by AC. After that, you can cross multiply. What is BC into BC? BC square is equal to CD into AC. Adding the equation number 1 and equation number 2. That is AB square plus AC. BC square is equal to what? AC into AD plus AC into CD. Now AC take it as a common. Remaining AD plus CD, which is equal to what? AC. So AC square is equal to AB square plus BC square. Now listen carefully. The next question. PQR is a right angled triangle. Right angle at P. And M is a point on QR such that PM perpendicular to QR. Such that we need to show that PM square is equal to QM into MR. Okay, now listen carefully this. In triangle PMR, using Pythagoras theorem, PR square is equal to PM square plus RM square. Put equation number 1. Now in triangle PMQ, using Pythagoras theorem, PQ square is equal to PM square plus MQ square. Now in triangle PQR, by using Pythagoras theorem, RQ square is equal to RP square plus PQ square. So RM plus MQ the whole square is equal to RP square plus PQ square. Now expand using A plus B the whole square. That is RM square plus MQ square plus 2RM into MQ. which is equal to what? Right side, RP square plus PQ square. Now adding equation number 1 and equation number 2. What we get? PR square plus PQ square is equal to 2 into PM square plus RM square plus MQ square. Now both one having PM square. So 2 PM square. Okay. From 4th and 5th, what we get? 2 RM into MQ is equal to 2 PM the whole square. Okay. So listen carefully. 2M the whole square. We need to prove what? 2 into RM into MQ is equal to 2 into PM the whole square. So PM the whole square is equal to twice of RM into MQ. That we need to prove. Clear? Now in this figure, ABD is a right triangle at A and AC perpendicular to BD. Show that first one, AB square is equal to BC into BD. AC square BC into DC. AD square BD into CD. Now the solution. First one, consider triangle BCA and BAD. From these two triangles, angle BCA equal to angle BAD, each 90 degree. In BCA and BAD, angle BCA is equal to angle BAD, each 90 degree. Now angle B is common between the two triangles. So triangle BCA is similar to triangle BAD using A criteria. So if two triangles are similar, we can write the sides as proportion. That is BC by AB equal to AC by AD equal to AB by BD. Corresponding sides of the similar triangles. And angle BAC is equal to BDA. So corresponding angles of the similar triangles. Now we can write the ratio BC by AB equal to AB by BD. Now cross multiply. AB into AB is AB square is equal to BC into BD. Hence the proof. Now next question. In triangle BCA and triangle DCA, angle BAC equal to angle DAC, each 90 degree. Now angle BAC equal to angle CDA from equation number 1. From equation number 2. Now these two triangles BCA and ACD are similar using AA similarity. So if that two triangles are similar, we can write BC by AC equal to AC by CD equal to AB by AD. Using what? Corresponding sides of similar triangles. The similar triangles, the sides are in proportion. So we can write what? BC by AC equal to AC by CD, or cross multiply. AC into AC is equal to what? AC square is equal to BC into BDC. Hence the proof. Now from equation number 1 and 3, what we get? Triangle BAD similar to triangle ACD. That is AB by AC equal to BD by CD equal to BD by AD. Now from that we can write that what? AD into AD, cross multiply the last two. AD into AD is what? AD square is equal to BD into CD. Hence the result. Now the next question. ABC is an isosceles triangle right angled at C. Prove that AB square is equal to twice of AC square. Now simple question this one. In triangle ABC, by Pythagoras theorem, AB square is equal to AC square plus BC square. Since triangle ABC is an isosceles triangle, AC equal to BC. Now from equation number 1 and 2, AB square is equal to what? Twice of AC square. Okay, hence the proof. Now the next question, ABC is an equilateral triangle of side 2A. Find each of its altitudes. So we need to find out the altitude. So first equation we need to consider area of the triangle is equal to half into base into height. Now area of the equilateral triangle what? Root 3 by 4a square. Equating this equation, root 3 by 4 into substitute what is side? 2a. The whole square is equal to half into 2a into height. Now root 3 by 4 into 2a, the whole square become 4a square. 4 and denominator 4 are cancelled. Remaining what? Root 3a square is equal to half into 2. So 2 and 2 are cancelled. What we get? Root 3a square is equal to a, which is the height. So height is equal to what? A root 3 cancel. Root 3a square by a. Then a square 1a and a are cancelled. At last what we get? Height is equal to a root 3. Now next question. Prove that the sum of the squares of the sides of a rhombus is equal to the sum of the squares of its diagonals. Now listen carefully. This quadrilateral ABCD is a rhombus with a O as point of intersection of diagonals. Now in triangle AOB and angle AOB, angle AOB is equal to 90 degree since diagonals are perpendicular in rhombus. Now by using Pythagoras theorem, AB square is equal to OA square plus OB square. Similarly, what? BC square is equal to OC square plus OB square. DC square is equal to OD square plus OC square. Now what is DA square? DA square is equal to DO square plus OA square. Now then listen carefully. AB square plus BC square plus CD square plus 2A square is equal to twice of OA square plus OB square plus OC square plus OD square, which is equal to 4 into, that is OA square plus OC square is also same. Okay, so OA square plus OA square is equal to twice of OA square plus twice of OD square. So 2 into OA square plus OD square. The OB square plus OC square plus OD square become what? 4 into OA square plus ODO square. Now we know what? Rhombus diagonal bisect each other. That is AO equal to OC. Now DO is equal to OB. Now AC is equal to what total? AO plus OC. So AC square is equal to OA square plus OC square plus 2AO into OC. That is apply A plus B the whole square, which is equal to what? 4 AO the whole square. Similarly, BD square is equal to 4 into OD the whole square. Now AC square plus BD square is equal to 4 into OA square plus DO square. That is AB square plus BC square plus CD square plus DA square is equal to what? When we substitute AC square plus DB square. Hence the proof. This one we need to prove that. Now the next question also same type. Listen. In given figure, from a point O in the interior of the triangle ABC, perpendiculars to OD, OE and OF are drawn to the side BC, CA and AB respectively. Prove that AF square plus BD square plus CE square is equal to OA square plus OB square plus OC square minus 2OD plus 2 OD square, OA square plus OB square plus OC square minus OD square minus OE square minus OF square. Second, AF square plus BD square plus CE square is equal to AE square plus CD square plus BF square. So listen carefully this question. So listen, let O be a point in the interior of triangle ABC and OL perpendicular to BC. OE perpendicular to OL. CA. OE perpendicular to CA and OF perpendicular to AB. Now in triangle OFA, triangle ODB and triangle OEC are in triangle OFA and ODB and OEC we have what? OA square is equal to AF square plus OF square. Then OB square is equal to what? BD square plus CD square. And OC square is equal to CE square plus OE square. Then you need to add all that. That is OA square plus OB square plus OC square is equal to AF square plus OF square plus BD square plus OD square plus CE square plus OE square minus OF square. OE square. So implies what? You need to prove this one last. AF square plus BD square plus CE square is equal to OA square plus OB square plus OC square minus OD square minus OE square minus OF square. So this one we need to prove. Now the next one, in right triangles. Next one also you need to prove for this question itself. In right triangle ODB and ODC, we have OB square is equal to OD square plus BD square and OC square is equal to what? OD square plus CD square. Now subtract. OB square minus OC square is equal to OD square plus BD square minus OD square plus CD square. Now OB square minus OC square is equal to OD square plus BD square what? BD square minus OD square plus CD square Put equation number 1. Similarly we have OC square minus OA square what? CE square minus AE square. And also OA square minus OB square is equal to AF square minus BF square. Adding equation number 1, 2 and 3 we get OB square minus OC square plus OC square minus OA square plus OA square minus OB square plus BD square minus CD square plus CE square minus AE square plus AF square minus BF square. Now next step, last one, BD square plus CD square plus AF square minus of AE square plus CD square plus BF square, which is equal to 0. So we can write what? If F square plus BD square plus CE square is equal to what? AE square plus BF square plus CD square. Hence the proof. An aeroplane leaves an airport and flies due to north at a speed of 1000 km per hour. At the same time, another aeroplane leaves from the same airport and flies due west at a speed of 1200 km per hour. How far apart will be the two planes after 1.5 hours? Now the first aeroplane leaves an airport and flies due north at the speed of 1000 km per hour. So if it is 1000 km per hour, we have to take what? We want to change the distance traveled in 1.5 hours is equal to 1000 into 1.5, which is equal to 1500 km. Similarly, distance traveled by second aeroplane is equal to 1200 into 1000 200 into 1.5, which is equal to 1800 km. Now listen carefully. Distance we need to find out. So speed is equal to distance divided by time. So what is distance? Distance is equal to speed into time. So 1000 into 1.5, first case 1500 kilometers, second case 1200 into 1.5, 1800 kilometers. Now in triangle ABC, BC is the distance traveled by the first aeroplane and BA is the distance traveled by the second aeroplane. Hence, applying Pythagoras theorem, AC square is equal to AB square plus BC square. That is 1500 square plus 1800 square. Now add it. First take the square, then add it. Hence, the two planes are at a distance of 360 kilometer, 300 root 61 kilometer. Okay, students. Thank you.